Okay, in this video what I'm going to do is introduce the concept of what's called a synthesis reaction, and actually this is going to be the first of 4 videos on classes of reactions, and so we're going to cover synthesis reactions, decomposition reactions, single replacement, and double replacement. And then a second objective in this playlist will be to practice balancing equations as we go along. So a synthesis reaction. All right. So a synthesis reaction is a chemical reaction which usually involves the combination of 2 reactants to produce a single product. One of the classic synthesis reactions out there is the reaction between hydrogen gas and oxygen to produce water. All right. And when we write the chemical equation, we write it this way so that we have the proper formulas for the these happen to be diatomic elements. Diatomic because in their natural form, lowest energy state, under ambient conditions, meaning atmospheric pressure that we have right now surrounding us, and roughly room temperature, these elements are going to exist as diatomic molecules. They combine to produce water. Now, you'll notice that the reaction's not balanced because there's 2 oxygens on the left side of the arrow, and there's only 1 oxygen over here. So the law of conservation of mass dictates that when hydrogen reacts with oxygen, that we have to have or we have to produce the same numbers and types of elements on both sides of the arrow. So in other words, we need the same number of oxygens on the right side of the arrow as we have on the left side of the arrow. So we're going to need to put a 2 here to equalize the oxygens, and when we do that, you see that we have a total of 4 hydrogens now, so we're going to need a 2 here. And now this equation is properly balanced. All right. Now the other thing is that although this is a synthesis reaction, it's also another type of reaction as well. You see that the hydrogen is actually being reacted with oxygen, and if you carried this reaction out for real, you would mix the hydrogen gas and the oxygen gas together, and when you provide a spark, you would see an explosion because the hydrogen gas is actually flammable. So this is also called a combustion reaction. And a combustion reaction is going to be any kind of reaction that involves some kind of a reactant that's combined with oxygen. All right. All right. Now the next example would be, again, it's going to be a reaction that involves hydrogen. This time around we'll react it with nitrogen to produce ammonia. Again, it's a synthesis reaction because we are combining only 2 reactants here, and we're producing a single product. Single product from 2 reactants. Okay, and we see again that the reaction's not balanced. We have 2 nitrogens on the left side of the reaction and 2 hydrogens, and we see that in the product there's 1 nitrogen and 3 hydrogens. So to balance the nitrogens, we're going to need to put a 2 here, and that means now that there's 6 hydrogens, so we're going to need a 3 on this side of the reaction, and now it's properly balanced. All right. Okay, the next reaction will be the reaction of iron. All right, which is an element that is a metal and it's solid, and it's going to be combined with oxygen gas to produce iron 3 oxide, which is Fe2O3. And just as an aside here, I said iron 3, and that's because the iron in this form, it's made an ionic compound, is actually Fe plus 3, and it's been combined with O minus 2. All right? And when it combines like this, if you're using drop charge, you can see how it is we arrived at the formula. All right, now this is a synthesis reaction because, again, we're combining two reactants to make a single product. But notice, too, that we're reacting the iron with oxygen. So this is also another form of a combustion reaction. So I'm just going to write that here to remind you that any chemical reaction where there's a reactant combined with oxygen is a type of combustion reaction. Now, let's look at the balancing, because like the others, this reaction is not balanced, and we see that we've got there's 2 irons here, and there's 3 oxygens. So what I'm going to do is I'm going to try putting a 2 here, and when I do that, that makes 4 irons on this side, and so we're going to add a 4 over here, and it means that there's a total of 6 oxygens, so we're going to need a 3 here. Okay, and when we test this, and quite frankly, balancing equations is trial and error. There's no real try and true method to this. You just need to try something and then count. So we have 4 irons here, we have 4 here, we have 6 oxygens on this side and 6 here. All right, so let's look at one last example of a synthesis. We have, in this example, we're going to take magnesium oxide, which is a solid, and we're going to react that with water, which is a pure liquid. And we're going to be producing, and if the student remembers their chemistry of group 2 metals with water, this is similar to that, because we're going to produce what we call a metal hydroxide, which is aqueous, meaning that this is an ionic compound now that's dissolved in water. All right, now, again, this is a synthesis reaction because we're combining 2 reactants and we're producing a single product. When we look at the balancing, we see that on this side of the equation, on the left side of my arrow, I've got 1 magnesium and I have 1 here. There's 2 oxygens on the left side of my arrow, and in this formula there's 2 oxygens here, 2 hydrogens on the left side, and 2 inside the parentheses. So this equation's already balanced. Now, as an aside, for a more advanced class, note that on the right side of the equation we've produced an ionic solution of magnesium hydroxide, and the rule is that if you have an ionic compound and it is dissolved, and we know it's dissolved because the designation here is AQ. That means that this compound is dissolved in water, and if an ionic compound is dissolved in water, that means its actual form is in the form of ions. So that means there's magnesium ion and there is hydroxide ion, and this would represent the actual form. So in a more advanced class, you might be asked to write the net ionic equation, and what that's going to look like is going to be this. Now, we do not separate either the magnesium oxide because it's a pure solid and it's a crystal, and we don't separate the H2O because it's a unique covalent compound, but we do separate the ions into their actual form for what we call the net ionic equation.